Hi, welcome to Subtracting with Fractions, both mixed numbers and fractions greater than 1, in addition to simple fractions less than 1. So title your paper. And make sure you write your date off to the side. And we're going to start with just a review. The numerator is your value at the top. Your denominator is your value at the bottom. You could also write this as a dividend divided by your divisor. And you can also write a fraction as your dividend or your numerator divided by your divisor or your denominator. So you can write it many different ways. You can also do this, numerator divided by denominator, because a fraction is a division problem. So we're going to start with adding subtracting basic values, like 1/2 take away 1/3. So when I write this, I'm going to do just like I'm doing a whole number problem where I would write it vertically to subtract. I'm going to do the same thing here to make sure that I know that I'm taking this value away, because sometimes we flop them and we cannot do that. There is no commutative property of subtraction. So I'm going to first find common denominators, and I know that if I look at 1/2 and 1/3, I know that a third has multiples of 3, 6, 9, 12, and a half has multiples of 2, 4, 6, 8, 10, and I could keep going on, but my lowest common denominator would be 6. So I'm going to multiply 1/2 by 3/3, which is equal to 1, to get an equivalent fraction of 3/6. And I'm going to multiply 1/3 times 2/2 to have common denominator of 6, because 2/6 is equivalent to 1/3. So then I just simply subtract. 3/6 take away 2/6 is 1/6. And that would be my solve. So 1/2 take away 1/3 is 1/6. So if I were doing this with fraction strips, I'd start with my base as 1. And I would take 1/2 here. It's a little bit inaccurate, but here's my 1/2. And to take away 1/3, I would put 1/3 down here at the bottom. And then I would just find the difference that's left over. That is how I would use the fraction strip. If I were drawing a model, maybe a bar model, I might draw out a rectangle, cut that into halves, because I'm starting with 1/2. I would shade in 1/2, and then I would find common denominators, and by doing that, I would cut this by thirds and this by thirds. So now I have 1, 2, 3, 4, 5, 6 pieces make up the whole. I have my common denominator 6. And then I would eliminate 1/3, which is equal to 2/6. So I would go through and I would cross out 1 of those shaded areas and then 2 of those shaded areas, and that would leave me with 1/6. That's my model method. And I could also do a number line. I would draw one number line. And I would start with 0. And I'm going to end with 1. And I will plot 1/2 on my number line, because that's where I'm starting. And then I need to think to myself, well, I'm going to find common denominators again, because we only subtract with common denominators. So I'm going to find common denominators, and I know that 6 already, because I found them here, is a common denominator of 2 and 3. So since I started with 1/2, I plotted my point, and I know that 1/2 is equivalent to 3/6. and I know 1 whole is equivalent to 6 6. I know 0 is equivalent to 0 6. So what I'm going to do is just count up and mark my tallies, or mark my my points between my number lines. So here's 3, so the next number would be 4, then 5, then 6. Oops, I'm sorry. Should have written that one there, should I? Let's go through with a different color so it's a little more clear. So 4, 5, and then I have 6 there already. So this would be 4, 6, and this would be 5, 6. And then over here, I have 0 to 3, 6, so I need 1 and 2. So I mark my marks, and then I put 1, 6, and then 2, 6. Those red were my mistake. I accidentally forgot that I already wrote 1 over here. So now that I have common denominators, I know that a third is equivalent to 2 6. Then I would just go backwards because I'm taking away on my number line 2 6. So when I do that, I would start at 3 6, which is 1/2, and I would go back 1 6, 2 6, and I stopped at 1 6. So that is my solve. That's my difference. So that's what we would do for our traditional fractions less than 1, finding common denominators. You could also estimate, that's another option, to find a reasonable answer. I'm not sure if I'm writing there. And when I estimate to find a reasonable option, I plot 2 values. So I'm going to ground to my benchmark fractions of 0, 1, 0.5, and 1. Because I have fractions less than 1, I won't have anything greater than 1. So if I look at 1/2 here, that is going to stay at 1/2. And then if I plot down here, 0, 1/2, or a third, I'm sorry, it's too early for me apparently, or 1, because 0 comes before a third, and then we have 1/2, and then 1, since our fraction is less than 1. And so now I say, well, where would a third fall? Well, a third is less than 1/2. It'd be about here. So I would either round up or round down to 0. But since a third is closer to 1/2, I would round a third to 1/2. And then I would just subtract. Instead of using my values that I have, I would use my estimation values. So 1/2 just stayed 1/2, but 1/3 rounded to 1/2. So my estimation is about 0. And if I look, 1 6 is pretty small, so that's near 0. If I were to round 1 6, I'd probably round it down to 0. So now we're moving into fractions that are larger than 1. And I'm going to show you mixed numbers with regrouping, because I feel like that would be a really good place for us to get some good understanding. Now let's say I had 32, take away 19. If I were using these whole numbers, usually I see students write it vertically. So that's what I want you to do whenever you're doing fraction subtraction as well. Write it vertically, and I would think to myself, can I have 2 1s and take away 9? Well, not without getting a negative number, and I have values to fair trade from or regroup from, so I can regroup or fair trade. So I would eliminate 10 rod, and I would add 10 over here because each place value that's a whole number is worth 10 times as much. So now I have 12, take away 9, 12 1s, take away 9 1s. That I can do simply, it's 3. And then 2 10s, take away 1 10, that would be 13. So my solve would be 13. Well, it's the same thing when you're doing mixed numbers that are smaller in value in one place value and you can't subtract. So we can fair trade. Let's say I have the value 1 3/4 and I'm taking away 1 5/8. Well, the first thing I need to do would be to find a common denominator between those two values. I have 3/4 and 5/8. So what's common between 4 and 8? I have multiples of 4, 8, 12. I have multiples of 8, 16. So I know that 8 would be my least common denominator, and that means I only need to find an equivalent fraction of 3/4 because these are already in 8s. This value is already in 8s. So 2 halves would give me an equivalent fraction of 3/4 and 8. 3 times 2 is 6, and 4 times 2 is 8. So now I have 8s, and I can take away my 5/8. Well, it's quite simple here because my 6 numerator is larger than my 5 numerator. So there's no regrouping necessary. 6 take away 5 would be 1, and those are still 8s. 1 take away 1, that would be 0, and there's no need to write the 0 there. So I know that this equals 1 3/4 take away 1 5/8 equals 1/8. Now, when I'm thinking about finding other values that require regrouping, like let's say this is mixed number subtraction. If I remember my whole numbers up here, let's say I have a value similar to 3 and 1/5 take away 1 and let's say 10/15. So now that I have these two values here, I wrote them vertically, which is important to do at first. I need to find common denominators. I know that 15 is common between 5 and 15, so I'm simply going to find a common denominator using 3/3 as my whole, and I will rewrite this as 3 and 1 times 3 is 3 and 5 times 3 is 15. Now I can go ahead and subtract. So just like before, I start in my smallest place value, which is my fractions over here, my fractions that are less than 1 in this area, and I have 3 take away 10. Well, if that was a whole number, I would fair trade just like I did up here. But it's not a whole number. I can still fair trade because I have wholes to fair trade from. Now the part that maybe we think, oh, this is easy, I get this, but we're not fair trading and adding 10. We're adding whatever is a common denominator. So when I regroup from my 1 wholes, I'll now have 2 in my wholes. And I'm going to add a whole with the same denominator that I have here. So I'm going to add 15 15ths because 15 15ths equals 1 whole. And that's what my denominator is. If my denominator was 2, I would add 2 halves. If my denominator was 5, I would add 5/5. So I want to add a whole in whatever my denominator is. And if I'm adding a whole, my numerator and my denominator need to be the same. So 3 plus 15 would be 18. And 15 and 15 I do not add. That's telling me how many make up a whole. Now this is not a proper mixed number because it has a fraction greater than 1 in it, but since I'm regrouping so that I can subtract, it's okay in subtraction. So 18 take away 10, and that's going to give me 8/15, and 2 take away 1 is 1. So that's an option with regrouping, or fair trading, as I like to call it. But you can also make it fraction greater than 1. So this is the option that I prefer. I will let you choose whichever one you want as long as you're showing me that you can get the value with accuracy. So I'm going to start with 3 and 1/5, take away 1 and 10/15. Now, I still need common denominators, but I am going to go ahead and find fractions equal to my mixed numbers. So I know that I do denominator times whole plus numerator. 5 times 3 is 15, plus 1 is 16/5. 16/5 equals 3 and 1/5, because I have 3 sets of 5/5 plus my 1. Then I'm going to do the same thing over here for my value I'm taking away. I have 15 times 1 plus 10. So 15 times 1 is 15 plus 10 is 25. 15. Now, I can't subtract yet because if I look at these, I do not have common denominators. So what's common between 5 and 15? Well, 15. So I know that I can use 3/3 to multiply by a whole to get the equivalent fraction in 15ths of 16/5. So 16 times 3, I'll write that over here to the side. 18, 3, and 4, that's 48. And then 5 times 3 is 15. Then I subtract. I already have 15s here, so there's no need to change my denominator. And then I subtract 48, take away 25. Well, 8 take away 5, that's 3. 4 take away 2, that's 2. So now I have 23rd 15ths. So this is as a fraction greater than 1. Or I can write that back as a mixed number and go, the numerator goes in the den, the numerator goes in the den, hi-ho the dairy-o, the numerator goes in the den. So 23 is divisible by 15 one time, I subtract 15, and I get 8/15. My remainder is my numerator, and my 15 is my denominator. And if you notice, that's the same thing we got up here. So you can try it the regrouping way, and if you can show me that you have that with accuracy, then we can keep using it. If not, we need to try out the fraction greater than 1 option. And that is it for our subtracting fractions.